Hello everyone, my name is Tankam Girija and this is a presentation for my final project, Twitter data analysis using Elk Stack. I'm going to begin with a brief introduction to Elk Stack. Elk Stack is a collection of 3 open source technologies, Elasticsearch, Logstash, and Kibana. Elasticsearch is a NoSQL database with very powerful search capabilities along with very good scalability. Logstash is a tool through which you can extract data, transform them, and load to and from several different sources. This is known as an ETL technology, extract, transform, load. Logstash can accept input from Amazon S3 buckets, from SQLite databases as flat file inputs, CSV files, from Twitter, from servers. It can collect server logs, application logs, error logs, etc. So it allows you to perform certain transformation on the data and lets you store the output in several sources. The output sources for Logstash again can include S3 buckets, databases, Elasticsearch, etc. So in my case, the input for my project is going to be Twitter data in real time, and the output will be stored in Elasticsearch server. So the last technology in Elk Stack is Kibana. Kibana is a web-based data analysis and dashboarding tool for Elasticsearch. So it basically allows you to make some sense out of the data by displaying them in several different dashboards. Next is my project goal. As I mentioned, the input for my project is going to be Twitter data. So my goal is to analyze Twitter data stream in real time and answer a few questions based on them. A single tweet can include several hundred attributes, like who is the user, what is the location of the user, what is the time zone, what is the language that it was tweeted in, was it a retweet or a new tweet, etc. So based on all these attributes, I'm going to specifically look for certain keywords in the tweet itself. So I'm looking for positive sounding keywords, or you can say mostly positive sentiment keywords, like I'm happy or I'm excited, relaxed, etc. So based on these keywords, I will filter the tweets, and I'm going to use Kibana to tell me which area have more positive sounding tweets than another area. This is a high-level view of the project flow that I just mentioned. So I begin by connecting to the Twitter API. I'll start pulling the tweets using Logstash Twitter input, filter them based on positive sounding keywords, store it in Elasticsearch, and visualize it using Kibana dashboards. Next is the environment and the tools that I've been using for this project. So I'm using Amazon AWS EC2 service for creating 3 instances out of a Linux AMI. And I'm installing Elasticsearch in one, Logstash in another, and Kibana in the third. And I'm also using a plugin for Elasticsearch called Head plugin, which can be very useful for seeing the indices for Elasticsearch cluster. So we'll look at that in detail when I'm doing the demo. Next, I'm going to look at each of the technology in the Elk Stack in detail. First one is Elasticsearch. As I mentioned, Elasticsearch is a NoSQL REST JSON API-based technology. It's schemaless and highly document-oriented. It allows rapid full-text searching using inverted index. It has ad hoc querying capabilities, and it is built on Apache Lucine's project. Next is the configuration of Elasticsearch. Setting up Elasticsearch is very straightforward. All you have to do is download the tarball, extract them into directory, and just edit the config file known as elasticsearch.yml. So I have to provide the cluster name. I've named it as Elasticsearch. I only have one server in my cluster, which is where my Elasticsearch software is installed. And then since I'm using Amazon AWS instances, I have to provide the AWS credentials, which is pretty standard, and I provide the region, the type, and the tag name. So I've given it a prefix of Elk. So that's basically the configuration. It's very straightforward. Next in the stack is Logstash. As I've mentioned, Logstash is used for collecting, transformation, and forwarding logs. Collecting log is the most popular use of Logstash. It can be used for collecting any kind of logs like application logs, server logs, error logs, etc. Even though it's used for log collection primarily, it can be used for analyze any kind of big data. As in my case, I'm using it for analyzing Twitter data in real time. So this is a technology that's based on JRuby. And this is a high-level view of Logstash flow. It accepts input through a source. Like I mentioned, it has S3 inputs, file, syslog, Twitter, etc. And you can apply filters to the data. You can use grep, grok, regex, gop, or a combination of these several filters. And then you store the output. You can store it in Elasticsearch, file, db, S3, etc. This is a high-level view of the Logstash config file. Setting up Logstash is also very straightforward. You again follow the same thing, download a tar, extract them, and edit the configuration file. You can name the config file anything you want. I have named it as twitter.conf. And as I mentioned, it has 3 sections: input, filter, and output, and we can look at each of them in detail. So this is the overview of the input section. As I mentioned, my input is Twitter, and it provides codec. Codec is mostly for the format of the data, so I'm asking it to give the data to me in JSON format. So this is pretty standard for accessing the Twitter API. So you have to download these credentials after creating an application in Twitter. And then the message format is again JSON. And these are the keywords that I've been mentioning. So here I'm filtering them based on happy, relaxed, elated, excited keywords. And full tweet is true, meaning I'm telling them to give me the entire tweet and not just a subset of them. And the other available inputs are S3, SQLite, file, syslog, XMPP, etc. The next section is the filter section. So there are several filter options available. You can use grok, grep, goip, ruby, mutate, etc. And I'm using mutate in my code. So what this does is it just filters out any data that has bad format. So if the data format is bad, it could throw a grok pass failure exception. So I'm asking them to remove those tags from my data, so I'll get a much cleaner data. So you can combine this with any of these filters that are available. Next is the output section of the Logstash config file. As I mentioned, I'm storing it in Elasticsearch. You have to provide the host, protocol, and index type. And there are several different attributes to it, which all of them are not mandatory. And this is how it talks to Elasticsearch. So in my case, I have to provide my the public IP of my AWS instance. And in addition to storing it in Elasticsearch, I'm also putting the output in stdout so that I can show you in my demo. And it's very useful for debugging purposes. So I'm telling to give the output in stdout in JSON lines format. And as I mentioned, there are other output options available. S3, you can send it to email directly, CSV, pipe, etc. The last one is Kibana. So this is an example of Kibana dashboard. This is from my own output that you're seeing here. And setting up Kibana is also very straightforward. You can download them into directory, and you have to edit Kibana YML file, which is here. So by default, Kibana listens to 5601, but you can change it if you want. So I have it as 5602. You provide the host. So Kibana talks to Elasticsearch using the setup by providing the URL here and the port number. And 9200 is the default port in which Elasticsearch listens to. And then preserve host is true. So next one is the demo, where I'll show the complete flow of getting the data, filtering them, and displaying it in Kibana. So I'm going to begin with my AWS servers, and I have 3 servers, one for Elasticsearch, Logstash, and Kibana. And for the purpose of the demo, I have all of them configured to a security group which has inbound and outbound traffic open to all. And from the AWS dashboard, I can access the public DNS and IP, which we will use later. So I have SSH'd into these servers using Cygwin. So I have one terminal open for each. So this is the terminal for Elasticsearch. And I'm already in my directory where Elasticsearch is installed. So if I'm doing an ls here, I can see my config file elasticsearch.yml, which I had showed earlier in the slides. So I'm going to go ahead and start my service for Elasticsearch using the command. So it looks like Elasticsearch started okay. You can also verify the service health by using the browser by accessing it through the public IP and the port 9200. So if you refresh, you can see that the status is 200. It's okay. So it's just another way of looking at Elasticsearch. So next I want to show you the Elasticsearch head plugin that I was talking about. So you access the head plugin using the same URL and port number because it's also installed in the same server as Elasticsearch. So this is a very useful web frontend for accessing Elasticsearch cluster. So as you can see in my indices, I don't have any indices, which means I don't have any data. And so my browser view is also empty. So this is where you would see all my tweets coming in and all my indices. So it's just a convenience for seeing them using the browser, using to see the data using the browser. So next I'm going to show the Logstash terminal. So I'm already in my Logstash directory. So this is where I have my configuration file. So I'm going to quickly open the twitter.conf file. So as you can see, I have an input section, filter, followed by the output, which I had shown in the slides earlier. So I'm going to go ahead and start Logstash using the command. So it's going to take a few seconds to start pulling data in from Twitter. So this is just a log warning that can be ignored. So in a second, you can see the dump in the std out, which we had requested via the file. So there you go. The data has started coming in. So I'm going to go ahead and stop the Logstash because otherwise it's going to just continue because it's pulling data in real time. So we might have just enough data to do our analysis for the demo today. So I'm going to go ahead and kill the Logstash server. So now if we come to our Elasticsearch head plugin and refresh it, we might be able to see our indexes. So you have one indices created, which is known as Logstash. And if you don't go to the browser, you can see we have around 61 records. So that might be enough for us for analysis for now. So each of the record here is a tweet. So we have like 61 of them. Actually, I'm going to go ahead and do it one more time to see if we can pull some more data for analysis. So I have let it run for a couple more minutes so to make sure we have some more data. So I'm going to stop it now and refresh the Elasticsearch head. So it looks like now we have 327 hits. So maybe we can now look at Kibana. So Kibana we access by using the URL, using the public IP and the port 5602, which we provided in the Kibana YML file. And so this is the default page. So as you can see, it has already identified our index pattern from Logstash as a Logstash star. So if you remember, this is the same name in Logstash. This is Logstash star, followed by the date. So next, I'm going to go ahead and pick the timestamp field available here. So this will allow us to see the data that was pulled in for a given time frame. So I'm going to pick it and say create. And now if you go to discover, so as you can see, my time picker is set to last 15 minutes. You can change it if you want. So this will ensure that this data that you're seeing is from my current run. You can change it accordingly. So as you can see, I have all this data that's pulled from Elasticsearch, and that is falling under different distributions based on the timestamp. It's you can up to seconds or milliseconds. So now we can visualize this using Kibana, using the Visualize tab. So I'm going to pick the pie chart because that's what I want to see my data in. So that would tell me this many people have positive tweets in this time zone. So I'm going to pick pie chart, select a new search. So I have the entire world that is showing here, meaning you don't see any slices. So all of my 327 count is falling under one distribution right now. So I'm going to split my slices based on certain fields that I want. So I give split sizes, aggregation, I'm going to pick terms. This will allow me to pick the fields that are available in my tweet. So I'm going to the bottom and picking time zone and apply. So this shows that my distribution for top 5 distribution, I can change it to say 20 or say, let's say 10 and apply. So as you can see, this time zone is US. So US time zone has got 168 tweets with positive thoughts. Eastern time zone has got 108 count, whereas Canada has got 168 count. So this basically what it tells you is that we can easily set up Elk Stack and analyze big data in just a matter of minutes with very minimal coding. Thank you.